All right, welcome back, Hononegah, Algebra 1. This is actually 3.5, day 2, so we kind of stopped in the middle there of section 3.5, so we're going to continue now in section 3.5. We're going to talk about slope and y-intercept again. So in this particular situation, I see it's a y equals equation, so the slope is 4, so y equals mx plus b, so the b value is -4. That means my y-intercept is at -4, so I have a y-intercept at -4 with a slope of 4. Now, how am I going to graph something with a slope? Remember, slope is rise over run. So how much it goes up and compared to how much it goes over. And if I have an integer like 4, that means the rise is 4. And the run is 1. So if you ever get a slope that is not a fraction, you can actually turn it into a fraction by putting it over 1. So if I'm going to graph this, I already know 1 point. And so now going up 4 and to the right 1 gives me another point. And going up 4 and to the right 1 gives me another point. And so that allows me to graph a line using just the slope and the y-intercept. So the rise over the run can help me to establish more points for the line. Now, the x question is about x-intercept, and this gets a little bit confusing. There's two ways of finding the x-intercept. Obviously, if I have a graph, I can tell you where it crosses the x-axis, and it crosses the x-axis at 1, 0. Now, let's say I can't tell for sure where it's crossing the x-axis. Then I can go back up into the equation and put, here's the original equation. I can put 0 in for y and solve it. So just like I did previously, if you put 0 in for y and solve it, you get the x-intercept. If you put 0 in for x and solve it, you get the y-intercept. So solving this, I'm going to add 4 to both sides and divide by 4. I get x equals 1, which I said previously just by looking at the graph. So the next one, again, I want to find the slope and the y-intercept. I want to practice on that step here in section 3.5. So I'm going to subtract 2x. And so I get a slope of -2 and a y-intercept at 0, 2. So graphing, 0, 2 is my point. How do I graph a slope of -2? Remember, slope is rise over run. So that means I go down 2 to the right 1. So down 2 to the right 1. So a positive, this would be a negative slope going downward. Now, again, I have the same situation as last time. I can find the x-intercept by looking at the graph. It crosses the x-axis at 1, 0. Or I can put 0 in for y. Whoops, sorry, I didn't write the equation down correctly. 0 in for y and solve it. It gets me an x-intercept at 1, 0. So the last one, a little harder. I'm going to subtract x and divide everything by 2. So I get -1/2 x plus 3. Fractional slopes are fine. There's nothing wrong with a fractional slope. That actually helps me. It gives me my rise and my run just by looking at it. And the y-intercept is at 0, 3. So I graph the point 0, 3, -1. So I go down 1 to the right 2. So a negative slope goes down and to the right, and a positive slope goes up and to the right. So now, again, I can look at the graph to come up with the x-intercept. The x-intercept right here is the point 6, 0. Or I can do it more mathematically speaking. I can put 0 in for y and solve it. And that would give me my x-intercept. So there's two kind of ways of doing it. One is just by looking at the graph, or one is putting a 0 in for y and solving it for x. The linear function g models the relationship in which the dependent variable increases 3 units for every 1 unit of the independent variable, and the graph when g of 0 is 3. Now remember when we did functional notation not too long ago. This means the x value that's plugged in gives me a y value of 3. So they kind of have to give you that. Okay, so that is your y-intercept right there. And then the 3 units to 1 unit So it increases 3 units for every 1 unit of the independent variable. So that tells me my slope is 3 to 1, or just 3. So let's graph this. 0, 3, with a slope of 3. Remember, 3 over 1, so it goes up 3 to the right 1, a positive 3, positive 1. And so I graph those, trying to make the line as straight as possible. And I see where it's crossing the x-axis, and it's crossing the x-axis at -1, 0. So the y-intercept using the functional notation, and the x-intercept using the graph. This is do it on your own. So take a second, hit pause, and see if you can do these 2 questions on your own. Welcome back. So I'm going to solve this for y. So I'm going to subtract 3x, which gives me my slope and my y-intercept. So graphing those, -3, 0, -3, sorry, is my y-intercept. Slope of -3, so -3 over 1 means it goes down 3 to the right 1, down 3 to the right 1. So there's the graph. And the x-intercept looks like it crosses the x-axis at the point -1, 0. If you decided not to do it that way, you can find the x-intercept by plugging 0 in for y and solving. So again, a little more mathematical way of finding the x-intercept is putting a 0 in for y. The linear function h models the relationship in which the dependent variable decreases by 2 for every 5 units of the independent variable. So now we're going down 2 over 5, so that's my slope. The h of 0, this is my y-intercept, is 0, 4. So that's enough information to graph. 0, 4 is the y-intercept, slope of -2, so down 2. Right 5, down 2. Right 5. And so I'm looking at the graph here, and I see that it's crossing at the point 10, 0. So my y-intercept, given the h of 0, and my x-intercept by looking at the graph. A submersible is exploring the ocean, begins to ascend to the surface, the elevation h, and the submersible is modeled by the function. So here we have a function where t is the time in minutes. Graph the function and identify its domain and range. Interpret the slope and the intercepts of the graph. So let's look at the slope and the intercept. I'm actually going to do B first. The slope is 650, and the y-intercept is at 0, -13,000. So what that means is my submarine, or my submersible, is -13,000. So it's down in the water, -13,000 feet. It's going up then 650 feet per second. Nope, sorry, per minute. Sorry, time is in minutes. So per minute. So every minute this is going to go up 650 feet. So what is the domain? What is the range? Well, I'm going to graph this. I would have liked to have graphed it in thousands. This graph is going to be a little more complicated to try to graph. I'm going to move this off to the side here. So again, in thousands, this would be at -13, 0 if I went by thousands. And then what would the x-intercept be? What if I put h of t as 0? Let's solve this for a second. So I would subtract, or add, sorry, 13,000 and divide by 650. So 13,000 divided by 650 would be 20. So what does that mean? What is 20, excuse me, an x-intercept at 20, 0 actually mean? Well, it's going to take 20 minutes. So if we went by twos, it would be here comes our sub, we're going up, we'll keep going up, and then we're going to stop right here at the point 20, 0 because our submersible actually hit the top. And so if you're looking at this from the domain's perspective, you're talking about from 0, this is t, to 20 minutes. That's how long it's taking the sub to go from where at the bottom to the top. And the range is from negative 13,000 all the way up to 0, because that's when we've hit the surface of the water. Your homework assignment tonight is another book assignment. If you have any questions, please make sure you reach out to your teacher, and good luck.